Today we're in section 9.2, simplifying square roots. Okay, so this lesson goes right off of the lesson that we learned yesterday. Yesterday we were approximating square roots. Do you remember that? We were taking the square roots of numbers. Let's say like the square root of 50. You're going to see that in one of our examples. And when we took the square root of 50 in our calculators, was it an even number? No, so we would round it. Didn't we round it? Yes. We rounded to the nearest tenth to get 7.1. Well, instead of rounding to the nearest decimal today, I'm actually going to take this and I'm going to simplify it but keep my radical. All right, so that's kind of where we're going with it. All right, so you've already sort of learned this, but now we're just going to look at it from a different angle. So the first thing we need to understand is something called the product property of square roots. The product property of square roots. And here's what it says. Take two numbers, take their square roots, and you get an answer. Okay? What's the square root of 4? Look at the first one. What's the square root of 4? 2. So here we go. And then what's the square root of 16? 4. And then 2 times 4 is 8. But then what it's saying is, instead of having it split up over here on the left, I can actually put them under the same radical, the same square root, and it's the same thing. What's 4 times 16? 64. And what's the square root of 64? 8. So it's still the same answer. Do you see, guys? So I can split it up, or I can put them under the same radical. It's still going to be the same answer. All right, so that's where we're going with example 1. Before we get to actually working a problem, I want to go over just a couple things about the simplest form. What does it mean to write an expression in simplest form? You're going to see it on your homework tonight. That's the instructions. Write the expression in simplest form. Here's what it means. No factor has a perfect square. There is no perfect square factor under the radical. So even though the number itself is not a perfect square, does it have a factor that's a perfect square? That's the question. All right, and then there's no fractions under the radical sign and no radical in the denominator. All right, so those are my other 2 rules. So before we start with these large numbers, I'm going to start with some small numbers first to kind of help us wrap our mind around this concept. All right, so let's take the square root of 12. I need to find 2 factors of 12, and one of them is a perfect square. You're going to hear me this whole lesson today say perfect square factors. What does that mean? I'm looking for a factor of 12 that's a perfect square. Well, let's review. What is a perfect square?
Something
that has a square root that's multiplied by itself to get to that number. So give me an example of a perfect square.
16.
4, 16, 64, 9, 100, 81, 121. All of these examples, okay, now let me talk. All of these examples are perfect squares because they have factors that can be multiplied by themselves to equal that number. So, can anybody think of 2 numbers that can be multiplied together and one of them is a perfect square for 12? 4 times 3. 4 times 3. And here's what the product property of square roots says. I can write it together or I can split it up. So I can take the square root of the factor that's a perfect square. See, if I look at it from the beginning, can I take an even square root of 12? Is that an even number? No. But I can break up the square root of 12 so that I can at least take the square root of one of its factors. That's all I'm doing here, is I'm pulling out the square roots of its perfect square factors. What's the square root of 4? 2. So I multiply 2 times the square root of 3. And that's my simplified answer. Okay? So you've got to know, guys, where does this number come from? It's because it's the square root of a perfect square factor of some other larger number. Okay? Let's look at the next one. Square root of 50. I want you to think of what two numbers can be multiplied together by themselves, and one of those numbers is a perfect square. Okay, find the perfect square factor. I'll give you a minute. Hey, what are my factors? 25 and 2. 25 times 2. And remember, guys, I can split this up. Square root of 25 times the square root of 2. Now I can take the square root of 25, and what do I get? 5 times the square root of 2. You think you can do this last one on your own?
Yes.
The square root of 63. All right, so let's say you're just kind of having a hard time with this. Here's a hint. Okay, I would just start with your lowest perfect square, 4. Is 4 a factor of 63? No. What's the next perfect square after 4? 9. Is 9 a factor of 63? Yes. So 9 times 7. All right, and I just went ahead and split it up. The square root of 9 times square root of 7. That's the same thing, guys. All I'm doing is just splitting it up. I can do that because of my product property of square roots. So what's the square root of 9? 3 times the square root of 7.
I did it.
It was just a typo. Now let's look at some bigger numbers. The square root of 180. Now it's going to get a little bit harder to figure out what my perfect square factors are. So here's what we're going to do. We're going to use our calculators, okay? And I'll stress the importance of one part of this that your calculator doesn't show you. Go ahead and take the square root of 180. What's your answer? 6 times the square root of 5. On your homework tonight, this is all you have to show me. So you don't have to show the perfect square factors. However, you have to understand where this 6 came from. How were they able to pull out a 6? It's because it had a perfect square factor inside it. So what were my factors inside before it got to my answer? If I pulled out a 6, what was my factor inside? 36. So in your calculators, what's 36 times 5? 180. You see how it works backwards like that? So this 6, guys, is on the outside because there was a perfect square factor that I could take the square root. All right, go ahead and do 300. And I'm going to ask you the same thing. What was its perfect square factor? And I need you to be able to tell me. All right, so what's the answer? 10 times the square root of 3. So what was my perfect square factor before I got to 10? It was 100. Because how did I get a 10 on the outside? I had to take the square root of some number, so I know that number was 100. Okay? Now I want you to do the third one. All right? The whole point of this, guys, listen, we can use our calculator all day long and crank out these numbers, but you have to understand where it's coming from. This number didn't just magically appear on the outside. It's because there was a perfect square factor on the inside that they took the square root of, okay? But they couldn't take the square root of the whole number because it wasn't an even number. All right, so what about 882? Very good. So what were the perfect square factors in 441 times 2, okay? So that's where the 21 came from because I could take the square root of 441. And those are my answers. Any questions on simplifying radical expressions? All right, so now let's add in variables. Okay, go ahead and now your calculator can't take the square root of variables. Okay, so you do need to know how to do that on your own, but we can take the square root of 24. What is the square root of 24? 2 times the square root of 6. But now the question is, what do I do with this s squared? Can I take the square root of s squared, and what would that be? Okay, so you have to understand something, and this is the way I explained it to 6 Hour. It seemed to help. 4 times 4 is what? 16. So what is the square root of 16?
4.
It's one of the 4s because it's the number that was multiplied by itself. It's not 4 times 4. The square root is 4 because that's the factor that was multiplied, right? So now let's look at x. X times x is x squared. So the square root of x squared is just x. In the same way that the square root of 16 was just 4. Does that make sense? Okay? The square root of x squared is x, the same way that the square root of 16 is 4. All right, so now let's look at these problems again. And again, you do need to understand that. All right, why is it just x? So since I can take the square root of s squared, I'm going to pull out an s, and that's my answer, 2s times the square root of 6. All right, and we're going to change this one to a 2, and we're actually going to change the third one. We're going to take it off completely. Okay? All right, so now let's try to work the second one. I'm going to give you a minute. What's the square root of 32?
8.
Yeah, no, wait. Square root of 32, guys. 4 times the square root of 2. Can I take the square root of x squared? What's the square root of x squared? Just x. Just like the square root of 16 is just 4, the square root of x squared is just x. So it's going to be 4x times the square root of 2. Look at the last one now. I already took the square root of 24 up here. What was it? 2 times the square root of 6. But now, since it's just r by itself, can I take the square root of r? No. I have to leave it under the radical. There is no, it's not a perfect square, if you will. It's not a perfect square exponent. I can't take the square root of r, so I leave it under the radical. All right, so now let's talk about division. With division, it can be split up the same way. You see how it's all together under the same radical in the first one, the square root of 100 over 4? Well, it can also be written the square root of 100 over the square root of 4. This is helpful if maybe I can't take the square root of the top, but I can take the square root of the bottom. Okay, so we can split it up that way. Here's how it looks in an example. The square root of 13 over 36. Okay, I can't just divide 13 over 36, but I can split it up. Square root of 13 over the square root of 36. Can I take the square root of one of those numbers? 36. What is it?
6.
So my answer is the square root of 13 over 6. Would you agree that there's no perfect square factors for 13?
Yes.
Yeah. 13 is simplified. It's even a prime number. So that's it. That's how I leave it. All right. Now, you can also put this in your calculator. Hit your square root button and hit the fraction button and enter the entire fraction, 50 over 81, and hit equals. What is your simplified answer? 5 times the square root of 2 over 9. But what does this 5 mean? Why is this 5 outside the parentheses?
Because 50 is a perfect square.
Well, 50 is not a perfect square, but it has a perfect square factor. What was its perfect square factor? 25. That's how the 5 ended up out there, because there was a perfect square factor inside that could be pulled out. Okay, that's why the 5 is on the outside. All right, go ahead and answer the third one now. What's the square root of 18 over 25? All right, what is it?
18.
3 times the square root of 2 over 5.
Yes, 3 times the square root of 2 over 5. There's no reason you should get that wrong. You should have put it in your calculator. But what does the 3 mean on the outside? Well, why is it there? Because 18, this number right here, 18, had a perfect square factor in it, didn't it? What was its perfect square factor? 9. So I could pull out the square root of 9. That's where my 3 came from. Do you see that? You see that, guys? That's how I get to my answer, 3 times the square root of 2 over 5. Now let's throw in some variables. Okay? So here we go. So we've already done the square root of 63, so we're not going to do that one. I want you to go ahead and find the square root of 54t squared. Remember what we talked about with variables. If they're a perfect square, I can take the square root. Okay? If some number can be multiplied or some variable can be multiplied twice by itself, then I can take the square root. All right? Try to find your answer. You think they have the answer?
Yes.
What is it? All right, who got it right? Good. What about the next one? Did y'all do that one yet? Okay, what did you get? The square root of 15 over 4. Okay, do you have leave your square root because you can't simplify 15 anymore. There's no perfect square factors. Go ahead and do the last one. Get.
4 times square root of 2 over 10.
Very good. All right, and that's it. Okay, so now we've got one more example, example 4. In this example, usually after really bad car accidents, the police will come out and just kind of investigate the scene. So that's the scenario that we're looking at here. Okay, they're measuring the length of the skid marks using the formula, the square root of 27L. All right, they want us to write that expression in simplest form. Go ahead and do that. Write the expression in simplest form, the square root of 27L. All right, what's it going to be? What's it going to be? 3 times the square root of 3L. I can't bring the L out. It wasn't squared. Okay, and L stood for what? The length of the skid marks. So now look. It gives me a length for the skid marks. Plug in that number and solve. Plug in that number. You're actually going to come up with an answer now. Okay, so what do I plug in for L? 125. So I get 3 times the square root of 3 times 125, which is 3 times the square root of 375. So let me ask you this. If you went up to your sergeant, you were the police officer to take this measurement, and you said, Sarge, I took the measurements you asked me to, and I figured out that the driver was driving 3 times the square root of 375 miles per hour. What kind of look do you think he'd give you?
What the heck are you
Okay, yeah. He'd say, what are you talking about, right? Like, that doesn't make any sense. So we need our answer to be practical. In order for it to be practical, we need to go ahead and convert this to a decimal. So if we did 3 times the square root of 375 and we change it to a decimal, what is going to be our answer? It's approximately, I need to approximate it, 58, stop please, miles per hour. And I'm recording the lesson, and so you actually, now that's on the lesson for today. Okay, so hopefully your mom doesn't listen to it. All right, stop disrupting my class. All right, so that's it for that lesson. Jonathan?
Why did 27 times 125 squared and I got this number?
Well, you didn't write it in simplest form. You didn't follow step 1, okay? But that's still okay. That's still okay. All right, so that's everything you need to know for 9.2.